Hello and welcome to the AESIN Tech Talk for Q3 2026. My name is Chris. I'm deputising for Gunny Dadyala today. You can register now for the Q4 edition of the AESIN Tech Talk. In a moment, I'll put the link in Zoom chat for those watching live or in the description if you're watching on YouTube. That presentation will be simulation, the backbone of AV assurance testing, and that's going to be with Elliot Herms, who is the UK Managing Director, Region Manager of Nordics. However, today's presentation is how to cut the cost of continuous cyber compliance, and that's with my guest today, John McNicol, who is the CEO of Nova Modus. Excuse me. Tripping all over my words already. If you have any questions or comments or observations on what you're about to see today, please put them in Zoom chat and we'll go through those a little bit later on. But now we cross over to Wiltshire. John McNicol of Nova Modus, the floor is yours.
Thank you very much, Chris. Much appreciated. Thanks for joining. The agenda for today is a little bit about Nova Modus, in case we haven't met or you don't know about us. And then I'll proceed to talk about the SecureTCU project that Nova Modus is involved with, and how that will cut the cost of continuous cyber compliance for connected vehicles. So first up, I guess, we should explain a little bit about Nova Modus. We've been involved in automated driving since 2014. Golly, a long time ago. Starting with the Ventura project, which used an existing self-driving wildcat on private roads, and a simulator, an in-person simulator to test public reaction. And the simulator and the wildcat were put through various traffic and road scenarios so that we could understand what the passengers and the other road users thought about them. There was also, following that, some work on pods or self-driving electric shuttles in the Flourish, the Insight and the Capri projects. This is the Capri project, which looked at services provided by this kind of vehicle for folk with impaired mobility, for example. We looked at safety whilst operating slowly amongst people in pedestrian areas. And we also looked at the insurance and legal issues of running these kind of vehicles on the road, and they, of course, have no brake pedal or steering wheel. So there's some legal implications there. That was followed a little bit later in 2018 by RoboPilot, which was we automated a new electric van for local logistics. That van was provided by Arrival. You may remember them in the past. And we developed a simulation test bench as well with those real roads, and we tested them around. And finally, the MyLink service, the autonomous passenger service, was set up by the Multicav project. That ran on a 2-mile route between Didcot Parkway Station and the Milton Park Business Park, Science and Technology Park. It's going over that bridge there, single track, controlled by a light. And we investigated how passengers and other road users found the service, self-driving, and most of the time, actually, the passengers didn't really know it was driving itself. And so based on those experiences in those automated driving projects, we got involved in some of the safety aspects of self-driving and automated driving. And the first thing that was involved is remote operation, or you might know it as teleoperation of vehicles. And we've done some research and some industry engagement, and then developed a standard on that basis. I am the technical author of the BSI Flex 1886. And just to note that there is another one, 1887. It deals with the human factors involved in sitting and teleoperating a vehicle. The AESIN is mostly about the systems on vehicle and off vehicle. And then I also got involved in standardizing minimum risk maneuvers or minimal risk conditions, what we combined into minimal risk events or MRX. And having done some industry engagement and research work, I'm one of the authors of the two BSI Flex 1888, which were the last one, version 2, was published in 2025, last year. And as the technology in self-driving became a little bit more mature, and of course, as the regulations and standards became a little bit more mature, there was considerable interest in cybersecurity for these kinds of vehicles. And Nova Modus then got involved in some automotive cybersecurity projects. And what I will do, I'll just list them right now, and I'll pick out a few learnings from these, and then we'll move on to the SecureTCU project. So first of all, there was a project called CavShield back, when was that? 2020, I think it was. And we looked at some approaches for the real-time identification and measurement of threats in a network of connected automated vehicles. At a somewhat similar time, funded through Zenzik, there's a ResiCav project led by Myra and Thales and BT, which looked at applying development tools and other software tools in the cloud in order to provide a dynamic real-time detection and testing of those kinds of vehicles. Followed later by the Res Auto project, and that actually looked at the memory safe processor. There's been some work, and AESIN have been involved in a couple of projects involving the Cherry memory safe processor architecture. And this Res Auto project looked at using that architecture in some electronic control units for automotive. And another one using Cherry was the Auto Cherry project, this one led by Beam Connectivity. And that looked at the Cherry processor in a telematics control unit, the entry and exit point to the vehicle. And finally, the SecureTCU project, also led by Beam, which has developed an approach to cut the cost of continuous cyber compliance. My plan now is to just very briefly rush through these. Each of these projects has mountains of publicly available information, but I will simply comment, really picking up some conclusions from these projects. The CavShield project was led by Honda, IBM, Toshiba, and Nexor were all involved using machine learning, which is a requirement, we thought, for getting and managing all sorts of unstructured data flows from vehicles. We also concluded that the machine learning would not be 100% effective, and so there needed to be a human supervisor in the VSOC or something like that. And crucially, the input and output verification of those ML models and the zero-day mitigations were very important when you start the process. ResiCav, as we mentioned, it assessed a technical and importantly, the economic feasibility of a methodology for cyber resilience called CyRes, unsurprisingly. That included methods to increase the probability of detection, metrics for measuring the probabilities of detection, and a roadmap to make all that commercially viable. And actually, although that was a short project, as was CavShield, it was followed by ResiCav Plus, which expanded the development work and included actually a legal report, which is using the measurements that ResiCav had calculated and developed as a potential for legal evidence in a court case. And there was also a compliance aspect looking at the real-time compliance of vehicles. And a conclusion was that it can be done economically. It can be viable economically. So those two projects were then followed by a project, as we mentioned. Auto looks at the Cherry processor. And one conclusion from that project was, again, that it's the tool chains, high quality, high integrity tool chains, well proven over many, many years, that are actually the foundation of safety critical systems in automotive applications. It also determined that those memory sort of errors Cherry is designed to find were much less common in a well-regulated, highly tested environment like automotive. And there are other commercial aspects there. One item was that stopping the system when it detects an error in memory usage isn't necessarily a good thing. It's essentially trading one risk for another one. And the other one is a real problem if you're in a safety critical ECU, for example. Moving on to the application of Cherry into a telematics control unit. So we're detecting memory failures in the entry and exit point to the vehicle, and we measured performance and security trade-offs in 4 use cases. We drove a vehicle, we installed it in a vehicle. You can see it in the Cherry unit, the Morello unit that uses Cherry, installed in the back of a Kia owned by Idiada, one of the partners. And we concluded out of that project that the connectivity TCU is more tolerant of the memory exceptions than many safety critical ECUs, because connectivity is often breaking and being challenged, can we say? So the TCU application was more tolerant of those added risks of Cherry. The cyber defense at the exit and entry points was very important, we think, for protecting in-vehicle networks. And there are a couple of other things that we noticed as well. We did run the Kia Niro around a test track and interfaced with the GLOSA traffic light system to check attacks on that system. And I think I'm going to summarize, if that's okay, some takeaways from that. I think from the Cav Shield project, a machine learning approach can be used to detect the threats in various data streams from vehicles. Can't be left to itself because it won't be 100% effective. It demands a VSOC support. The ResiCav methodology also used off-board compute that was tightly linked to the development tool chains. You're effectively using versions of development tool chains in a operational scenario. Auto also proved beyond doubt that the tool chains are the foundation, contrasted against some of the semiconductors focused, some of the Cherry semiconductors that were the focus of those projects. And the Auto Cherry project also concluded that. So those takeaways guided how the SecureTCU project was formed. Rapid intrusion detection at the communications gateway, collection of the security events from the vehicles, including processor hosts, CAN buses, and even the cellular Ethernet interface. We're doing the analysis in the cloud using machine learning. And for that reason, we can rapidly evolve IDS capabilities. We can do an automated playbook depending on the what the threat detected is. Although, as we've said, automation has its limitations. And one of the key things that in the cloud capability allows is it aligns and tightly integrates with the HARA and the TARA that are produced for vehicle approvals. So you can use them for ASPICE audits and compliance with standards and such like. And that will be effectively a real-time or at least a continuous compliance capability. Just to let you know that the project was funded bilaterally, so Beam Connectivity and Secure Elements are UK partners in this project. Both are AESIN members and are funded through Innovate UK. And AutoCrypt and Cartech are both Korean partners funded through their equivalent organization called KIAT. So that's a brief outline of the history of Nova Modus and how we came to be involved, what we've learned from those projects, and how that has been embedded in the project that I want to talk about. So I do have a quick video that I hope to will go well. Start the video again.
Connected vehicles will always have vulnerabilities, no matter how much time, effort, and money you spend. Today's connected vehicles must meet UNECE R155 and R156 for cybersecurity and software updates. The business critical issue is the rising cost of monitoring, detecting, and assessing.
Oh, come on, what happened?
Assessing anomalies, and then responding with vehicle software updates. Detecting and assessing anomalies to determine a safe and secure response can take days, weeks, or even months. SecureTCU delivers rapid in-vehicle threat response and lowers compliance costs. Watch out for more information coming soon.
We got there, John.
Excellent. Thank you. Thanks, Chris. So there's a little bit more information coming soon. But Chris, you wanted to talk a little bit about the conference. So you want to do that now?
Yeah, I do. So John is just switching over his slide deck. Let me just add myself to the main screen. There we go. So just whilst John fiddles around with that, and again, by the way, apologies for that technical snafu that just occurred. That's not embarrassing much. The 2026 TechWorks Semiconductors to Systems Summit is going to be happening in London, in Hammersmith at the Novotel London West on Wednesday, the 26th of August, so just over a month's time. So AESIN's parent organisation, TechWorks, is celebrating its 30th anniversary this year. So what we thought we'd do, rather than have the individual AESIN conference and have the individual conferences of our other communities, so the IoT Security Foundation, NMI, Design, etc., we thought we'd bring them all together under one roof for one day and have one big summit. So as I say, it's occurring at the Novotel London West in Hammersmith on Wednesday, the 26th of August. If you would like to attend, please register now, whilst there's still plenty of time to do so. There's going to be several auditoriums. So there's going to be one for the IoT Security Foundation. There's going to be one for AESIN and Design. There's going to be one for the NMI as well. So it really is going to be a fantastic event. We're expecting 600 plus people. I think we've got something like 60 exhibitors, perhaps even more by now. Don't quote me on that. In any case, the number is a lot, and this event is a big deal, which you don't want to miss out on. So please register now. The link, if you scroll back in Zoom chat, if you're watching live, is there. You can read the agendas, see all the speakers, and read a bit more about it, and also get yourself registered. John, are we ready to go again?
I believe so.
All right, just fire up your slides.
Okay.
By the way, whilst I'm on screen, again, if you've got any questions, comments, or observations for John and you're watching live, please put them in Zoom chat. If you're watching on YouTube, by the way, the link for the 2026 TechWorks 30th Anniversary Semiconductors to Systems Summit is in the description.
Okay. You see those, Chris?
Not quite yet.
Okay.
Nice. Sharing your
Bear
screen.
with loads of technology.
I'll come off the screen.
Loads of technology.
There we go. We're so slick today, aren't we, John?
Excellent. Right. Hopefully you can see them.
Getting there. I think it's... There we go, John. You're good to go.
Excellent stuff. Thank you. So, yes. So this is the one that you've just seen. Intrusion detection at the gateway of the TCU, collection of events, cloud-based machine learning to do threat analysis and responses, and over-the-air updates to fix things, all tied in to the standards, regulations, the compliances that we need. So if I may, just a couple of quick highlights to the partners in the current project, SecureTCU. Probably being connectivity and their solutions for TCUs and cloud monitoring of vehicles, etc. I won't spend any time in detail. We can supply more information if you need them. Secure Elements from Sackett, a cloud-based offering helping with both software development and the VSOC with a simulation component in the cloud as well. AutoCrypt have got a very wide offering and are essentially a very big player in automotive cybersecurity in Korea. And CARTEC, the Korea Automotive Technology Institute, is essentially a university research organization. I guess a little bit like some of the ones we have in the UK, but that they're government funded. They have a number of test tracks that the SecureTCU project is operating on, and they research everything from materials for tires all the way through to cybersecurity and teleoperation, among other things. So again, this is what we determined was the issue: rapid detection, rapid response to cyber events in connected vehicles. Is it a real event? Do we need to respond? How do we need to respond? And of course, all of that in line with standardization and regulation. And this is the TCU solution. There's a threat lurking somewhere, particularly, of course, a wireless attack through the TCU. It's just where our focus goes. And we've integrated the AutoCrypt intrusion detection system into the TCU hardware. And of course, that then sends a security event once detected into the cloud. There's an analysis, a potential playbook, but certainly a response. And, if software needs developing, then that will take a little bit of time. But assuming that it's a similar thing to what has already been detected and mitigated through the TARA, then a response can be sent down to the vehicle, in a matter of minutes, maybe hours, which is significantly better than some of the hours it might take other solutions. And that's the SecureTCU project. Yeah, as you can see the guys doing the demonstration in that photograph on the right there. That's the vehicle on the left. The black van is where the teleoperation control is situated. And the Renault vehicle on the right has our TCU plugged into it, along with a range of sensors and other things for teleoperation. So the teleoperator, the remote operating driver, sits in the van and controls the silver Renault from a distance. And because it's on a test track, that's why the van is mobile as well. Yes, so I think we've covered most of that, and we think that that will give a much quicker response in most cases, and will significantly reduce the cost of supporting vehicles. And if you happen to be a bit techie and you wanted to know something more, a little bit about it, there at number 1 over here on the left was the initial analysis of the functional safety of the TCU and the vehicle against the various regulations. Number 2 is the essentially confirming that the regulations and standards are met with the TARA. That goes into the SecureTCU. Number 3 there, yeah, we're missing number 3 there, is the integration of the TCU into the Renault vehicle. It's worth noting that the CarTech people have a long-standing and close relationship with Renault, and for that reason they were able to access Renault's CAN DBC file in order to operate the vehicle remotely. So they're a key part of that integration. We did a range of testing of various kinds. Number 4 and number 5 is where we put that back into the Crystal from Secure Elements for analysis and playbooks to respond to it. It's actually the Beam over-the-air update facility that we're using to update the software on the TCU. And we can pass through the TCU, so we can update other ECU software. But in this project, we're simply updating the TCU software and mostly the IDS policies. So, quick recap, forgive me for that. On vehicle detection, 5G TCU at the point of entry. Yes, I think we've covered all of those. Yeah, continuous defense, the benefit, continuous defense, continuous compliance, and the quickest way to respond at the lowest possible cost. That's the SecureTCU project. It will complete at the end of October of this year when we present the results and demonstration at the Intelligent Transport Systems World Congress, ITS World Congress in Korea. And that will be the conclusion of the project. So thank you very much for that. I have some questions that we can discuss, but let me ask if you've got any questions yourselves, please.
Hi, John. I'll kick off with a couple of questions. Let's
Thank
get
you.
you back on screen. And let me just fiddle around for a second. There we go. Okay, so to the Q&A section of today's broadcast. And John, one of the things I'd like to ask is, do you envisage that SecureTCU will replace security features in other gateway ECUs in vehicles?
So it's not, first of all, it's a research project, so we weren't trying to boil the ocean. We were simply addressing the TCU and the threats that can enter through the TCU. So the short answer to your question is not really. There'll be other intrusion detection systems in other ECUs distributed throughout the vehicles, we think. but we wanted to use this because it's the entry point and exit point to the vehicle. And for that reason, we're focused on the TCU. I hope that answers it. Hope that's clear.
Thank you very much. Question from Dominic. Which high-level risks is cybersecurity in autonomous vehicles intended to mitigate? Cyber attacks are just one of many threats to safe operation, and overzealous cybersecurity can lead to a loss of functionality more frequently than the denial of service attacks. That's from Dominic.
Yeah, thanks, Dominic. That's a good question. Yes, so I think I'd like to say that we are the SecureTCU project that we've just described isn't specifically targeting automated vehicles, autonomous vehicles. We are looking at the entry point and exit point of connected vehicles, is what we're doing. And we've chosen to use the teleoperation as a use case for the demonstration purposes. But we, of course, and teleoperation can be used, will be used in almost all autonomous vehicles somehow or other. But certainly I accept that the autonomous vehicles have lots and lots of different types of risks, software risks, and need all sorts of cybersecurity. For example, if you've got an autonomous vehicle which is analyzing videos, of course, then the training of the model, the training of the AI model is a key aspect, and it's a supply chain problem from that point of view. Cyber attacks are indeed one of many threats to safe operation, detection of pedestrians walking out in the road, and numerous other things as well. That's part of what I was trying to worry about when we talked about the MRX, the standards for minimum risk events. So I don't know. I think I've not really answered your question, Dominic. Apologies for that. I've essentially ducked it a bit and say that we're focusing really only on the connectivity.
Dominic, if you want to follow up with that, roll a couple of grenades, feel free. We're not here to deal with any easy questions, so hold John's feet to the fire. John, I'd like to ask you, a real problem with deploying intrusion detection in vehicle ECUs is the number of false positives causing new exceptions and failures. Have you thought about that?
Yes, indeed. Yes. When we talk to all sorts of folk in the industry, Korean motor makers, for example, and UK motor maker as well, when we talk to those folk, that's one of the things that they worry about if they install intrusion detection stuff into ECUs anywhere in the vehicle network. If you have a lot of false positives, then you can essentially make it unworkable for a user or an operator or a supplier, in fact. So yes, we certainly did think about that. And I guess that ties to your previous question really about the entry and exit point. We're focusing on that connectivity point. So we have enabled a machine learning approach for the analysis of the QSEVs, and a playbook, an automation type of approach, human supervised, to update the policies in the IDS system. So our idea is that rapid response to updating IDS policies can substantially reduce the number of false positives and make it a workable solution for suppliers and manufacturers.
Okay. Why have you chosen to demonstrate the SecureTCU approach in a rather esoteric teleoperation stroke remote operation use case?
Well, it's kind of esoteric. Having worked on a standard for remote operations, the number of people who are using teleoperations itself as a standalone thing is somewhat limited, but I think it's an emerging thing. That's the first thing. It's a coming capability, and I think almost all the autonomous vehicle makers we've talked to ever have used a remote operation or a teleoperation capability in some way, because the automated driving systems, the autonomous functionality, isn't yet 100%, getting there bit by bit, I guess. And therefore, operators of vehicles, manufacturers of vehicles need a way of getting an autonomous vehicle out of a problem. So it's an emerging kind of application, and one of the key reasons that we used that is that the guys at CarTech who are doing the testing, they have quite a capability and a history in that technology. But I guess the key reason from a commercial point of view, if you like, an exploitation point of view, is that the teleoperation demands a pretty rapid response. So if you're operating a vehicle and you have some kind of threat, vulnerability problem at the communications point, then you can't teleoperate it anymore. And therefore, a rapid response to detecting the threats and sorting that out, updating software if it's necessary, is an important feature in teleoperation. So 2 reasons why we chose teleoperation.
All right, thank you very much, John. We're coming up on the 40-minute mark. I've just put, for those watching live in Zoom chat, a link to register for another webinar that we're going to be doing later on today. It's a double shift for me. It's the IoT Security Foundation, another one of the TechWorks communities, alongside AESIN, and that's going to be a Beyond Cyber Resilience Act special. So if regulation is your bag, then please register for that one if you can manage 2 webinars today. Otherwise, the recording will be on YouTube as well as this one today. Thank you very much for your time today, John McNicol, CEO of Modus. So as I was saying previously, the TechWorks 30th Anniversary Semiconductors to Systems Summit takes place on Wednesday, the 26th of August at the Novotel London West in Hammersmith. Please get yourself registered for that one. All details are on the TechWorks website. You can see all of the speakers, all of the juicy talk titles, etc. It's going to be an absolutely fantastic day. In the meantime, thank you for joining us on this quarter's AESIN Tech Talk, and we'll see you again in October, when it will be Simulation, the Backbone of AV Assurance Testing. That's with Elliot Hermes, or Herms, forgive me, who is the UK Managing Director, Region Manager of Nordics. Thanks again to you, John, for today, and we'll see you all again next time.